Good afternoon, everyone. Today we discuss about polyhedral skeletal electron pair theory and total electron count theory. Yesterday we discussed about low nuclear classification of clusters. Today we discuss about what is the Watt's rules and again total electron count. Again yesterday we discussed about the total electron count also. Again the metal carbonyl scrambling. The metal carbonyl scrambling means the fluxional behavior of a particular carbonyl group, either bridging group to sideway group. It is the interconversion of cis and trans positions. This is the cis compound. This is the trans compound. So here the fluxional behavior is going on in the carbonyl based on the carbonyl. We discuss about this metal carbonyl scrambling. Again, we discuss about Watt's rules. The Watt's rules, again we calculate the MCO taken thrice. This unit is replaced by the BH unit. Again, we calculate what is the electrons, the valence electrons of the metal cluster, how many electrons are donated by the carbonyl, how many electrons is given by the negative charge. Again, if the heteroatom is present in a cluster, we add the valency of electrons of the particular atom. So but again we does not this MnCO for taken thrice be replace the BH unit is nothing but a non-skeletal electrons. Non-skeletal electrons means this one. Skeletal electrons means how many electrons are involved in the bonding. It is called as skeletal electrons. So again the non-skeletal electrons, the MCO taken thrice. Again the total electron count, according to the total electron count, the total electron count is equal to skeletal electrons plus non-skeletal electrons. Skeletal electrons is nothing but 2 into n plus 1. The non-skeletal electrons 12 into n. This capital N is nothing but how many number of metal atoms present in a cluster. Again the small n is nothing but it is fixed for any cluster. It is nothing but vertices. So how many is there? 6 vertices is there. If any cluster we calculate the particular this 2n plus 1 is nothing but 7. Again the n value is always 6 is fixed. For example, if you that we go for the capping rule. In the capping rule, the number of more electrons. If for example here osmium 7 CO 21. So about our 6 vertices we have one more metal atom is there. So this metal atom is take the hydral structure of a capping. Is nothing but hydral means it is a one of the face of a octahedral. So this is like this one. So this hydral face is occupied by the metal atom. So it is nothing but called as cap are appended added of an atom. So the capping rule is explained many carbonyl clusters which consist of a central polyhedron to which one or more additional metal atom is appended means added for the particular the triangular face, and we by over the triangular face, and these additional atoms are called as capping atoms. This capping atoms does not change the skeletal electrons. Skeletal electrons is nothing but 2 into n plus 1. So it's required simply increasing the total number of 12 electrons. What is about these 12 electrons? How can we get these 12 electrons? So again we go for the previous one. The in Watt's rules the BH unit is replaced by MCO taken thrice. So this MCO taken thrice is nothing but one dot in a particular cluster. So this dot indicate MCO taken thrice. Each metal atom is coordinated with 3 carbonyl groups. So each carbonyl act as a, you already know in the first semester we discussed the carbonyl act as a strong ligand, how it be good act as good sigma donor and pi acceptor. So when the giving of sigma donating of one bond is nothing but 2 electrons, and the pi donor is pi acceptor means again they take 2 electrons. So to total conversion, it is a line, it is indicate by 1 2 3. The line indicate again bond donating and accepting, both are is taken place. So there are 4 electrons are exchanged in a particular this molecule. So how many is there? 1 2 3. So according to these 3 into 4 electrons are transferred, so total 12 electrons. So it is this 12 number of electrons is fixed for any cluster where 12 into number of metal atoms. So the total electron count is calculated according to the polyhedral electron theory. So total skeletal electron plus non-skeletal electrons. So again we already know, as we discussed about total electron count is nothing but the valence electrons present in a metal atom and the electrons donated by ligand. How many negative charges added to particular complex we get at total, we get that total electron count. So this total electron count is substituted in the particular this complex. 86 is equal to 2 into n plus 1 plus 12 into how many metal atoms is there? 6 metal atoms. So write down 6 here. So 2 into n plus 1 is equal to, so it is comes 86, 12, 7, 12, 6, 72. So how much we get? 14. So n plus 1 is equal to 14 by 2. It is called as 7 electron pairs. So n plus 1 is equal to 7. N is equal to 7 minus 1, 6. So this vertices is nothing but the 6 is fixed, I already told, whereas 6 vertices in an octahedral complex. So one more of electron is added to particular this cluster. So it is explained by the capping rule. So here we calculate what is the total electron count, again what is the valency of this particular complex is